promised you on the quotient rule. So when I have division or a fraction, which that is, I need to do a derivative in a different way. So our rule, quotient rule, says that if we start out with a fraction or a division problem, we could change it into a fraction, that we use the u for the top, the v for the bottom, numerator, denominator, then the derivative is u dash v minus v dash u over v squared. So this essentially is the u component, so the u dash would be 2x minus 6. And this down here is the v component, and so the v dash would be 5. And I'm not going to apply the rule right now. I'll do it for my next example down here. And we're going to do a limited amount of simplifying. We're not going to do too much simplifying. Okay, but I'm going to point out some things that people trip up on once in a while. Okay, so this one, A, and I'm going to write it, I think I'm going to write it over here. A says, what are u and v? Okay, well, u is the top, so it's 3 minus x, and v is the bottom, so it's x squared plus 4x. All right, now I'm going to work over here because there's more room. For b, it says, what are the derivatives? So u dash, well, the derivative of that is negative 1, and the derivative of that is 2x plus 4. I think right away you should think of these things in brackets, maybe even this in a bracket, but definitely that, because it's coming as a sum altogether. So when I'm multiplying by this whole thing. So it asks me to find d dx of uv. In our world, that just means f dash of x, if this thing is f of x, or y dash. Okay, so I'm going to write y dash. So y dash equals, and I'm going to use my formula that's right up here, and I would write it down every time for a little while. I would say, okay, it's u dash, so that's negative 1 times v. All right, v has to come as a whole set, so x squared plus 4x in brackets. It's got to stay in there. These things are all bracketed. Minus v dash, which is that one, 2x plus 4 times u, so that one, all over v squared. We almost never do anything with that bottom. Try to get rid of that thing there. We almost never do anything with that bottom. But the top we could simplify. We could expand it, and we could get negative x squared minus 4x minus 2x, ooh, no, goodness, minus, and then I could expand this right here. And I could expand all that. And I'm just going to do that up here first and get 6x minus 2x times x minus 2x squared. And then that's plus 12. And that's minus 4x. So in here, 6x minus 4x, that's 2x minus 2x squared plus 12. So that's, and I have that whole bottom part, x squared plus 4x squared, that goes with me. The only reason I'm simplifying this is to show you what you might have to do to read the back of your book. So now I have negative x squared minus, well, let's do it like this. I'm going to head over here for the room. I didn't do this in your regular notes booklet, but I'm going to do it here. Negative x squared minus 4x minus 2x, I got to take that negative all the way through, plus 2x squared minus 12, all over v squared, x squared plus 4x squared. And if I simplify that, I get these two combined give me x squared, these two combined give me negative 6x, and then minus 12. So that's probably the answer that would be in the back of your book. But on a test, right now I'm saying, I don't know, I think this is a pretty good answer. Okay, and on your exam, it probably will say don't simplify. All right, let's see where I am in the timing here. Okay, let's keep going. We'll do this one. So it says, sketch the function. We decided we weren't going to do that. We decided we were just going to figure out the stationary points. Okay, and so this is what I did. To figure out the stationary points, I know I have to take the derivative and set it equal to 0. So I say u equals x squared plus 4, u dash equals 2x, v equals x minus 2, and v dash equals 1. And now I'm going to move up here, and I go, okay, y dash, or dy dx, if I was better, would go u dash v, 2x times, remember to bracket if it's a sum or a difference, minus these two, all over this. And so I have that y dash is 2x squared minus 4x minus x squared minus 4 over x minus 2 squared. It will pay me now to get this simplified because I'm going to try to solve it for 0. Sorry, minus 4 over. Did I do something wrong? I think that's 1x squared. Sorry. 2x squared minus x squared is 1x squared. X minus 2 squared. Okay, I'm going to set that equal to 0. Now this is what we talked about in class. We said that if a fraction is equal to 0, the bottom cannot be 0. I'm not allowed to have the bottom 0. So in this one, x cannot be 2. I know that because it would make the bottom 0. But if the top is 0, the numerator is 0, then the whole fraction is 0. So when I'm doing these problems right now, I can say, okay, I know that if x squared minus 4x minus 4 equals 0, then this whole fraction is 0. Now, in class we said, could we factorize this? And people didn't know, and we said, okay, well, we use the discriminant, which is b squared minus 4ac, and we did that, and we got negative 4, which is 16 squared minus 4 times 1 times negative 4, and we got 32. And 32 is not a perfect square. And if it's not a perfect square, the discriminant, then it cannot be factorized. So if I know that, then I can say, okay, well, then I'm going to solve it like this. I'm going to get the opposite of b plus or minus the square root of blah, 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 32. I already did it. That goes under there. So it was good to do it. And then on the bottom, 2a, so 2. All right. And then if we take that and stick it into the calculator, we get 2 points. All right. So I'm going to do a 2 plus square root of 32. Oops, divided by 2. So I got 4.83. And when I do the other one, the 4, sorry, this is the plus 1 and the minus 1. Like if I use the plus, I get that. If I use the minus, I get 4 minus square root of 32 divided by 2. I did it the same again. 4 minus square root of 32 divided by 2. Sorry. I get negative. So that just gives me the x coordinates, and I have to plug those back in to the original equation all the way up here. I have to plug those back in to get that. My other option is actually graphing, and I'm just going to do that quickly. I have it typed in already, is actually graphing that. And I can see what it graphs to. And I can go in there and I can go, all right, I'm going to go second calc, and I'm going to get that maximum value that I can see there. Now, that's the minimum. This is the maximum. So I got to get all the way over to this other graph. So I got to really hold it, get over there. So I'll go left-hand side, right-hand side. And I can see negative 0.828. I can see that one. And I get negative 1.66. And then if I want to find the other side, calc, that's a minimum because it's concave up. So I'll scooch all the way over there again. The thing kind of disappears. And I go left-hand side, right-hand side, enter. And I can see the 4.83. And then I get 9.66. Okay, okay? Because I can see these on the graph, and you should be doing that. And if you did that on a test, for instance, and you wanted to show how you got that, you would say max and min on GC. Maybe calc the max and min on GC. Okay, so you could show how you got it. All right, that's long enough.